Hey guys, what is up? This is Austin from the Crypto Gym. In today's video, I want to do another Ethernaut challenge. Today's video, I want to focus on level 4, which is telephone. And this challenge right here, it's pretty simple, but it's actually pretty cool. It teaches you something that's very important in Solidity and something that's very important to understand here. And that's the difference between transaction origin and message sender. So if we scroll down here, we can see the contract. It's a pretty simple contract. It's only like 20 lines of code here. I'm going to go ahead and click on Get New Instance. And let's send this transaction. And while that's pending, let's go ahead and open a new window in Remix. And let's go ahead and make a new file. We're going to call this telephone. So the transaction went through. Let's go back to Ethernet. So we can go ahead and copy this from here. And let's paste this in Remix. Go ahead and save so it will compile. And we can go to this tab and let's drop down to injected provided MetaMask. And we're going to grab the address from the console. Copy this from here. And we're going to paste this at the address and we're going to load the contract. So let's go back to the contract, or let's actually go to Ethernaut and let's see what our challenge is, what the goal is. It says claim ownership of the contract below to complete this level. So we want to become the owner. So we have address public owner. If we look at the owner, we can see that it is not us, and we want to become the owner. On the constructor, the owner set, and it says function change owner. It takes in an address called owner. Public, if the transaction origin is not equal to the message sender, then we become the owner of the contract. So basically what you can do through the EVM is you can have a contract call another contract. So me as the wallet address here, I can deploy a contract, and that contract A can call a function on contract B. The message sender, according to contract B, would still be contract A, but the transaction origin would be my wallet there. So me as the origin, me as the wallet is going to deploy another contract. We'll call that contract hack, and that hack contract is going to call the function on this telephone contract. On the telephone contract, the message sender is going to be the hack contract, and the transaction origin would be my wallet. So let's make it happen. So we're going to make another contract, which calls hack. And what we'll do here is we'll take our reference to telephone. So we're going to say telephone, call it TF, make it public, why not? TP for short. On my constructor, what we'll do is we'll set TP equal to, TP equal to telephone at this address. Copy that. So now we have reference to this contract deployed on the Sepoya network in our hack contract. And what we'll do is we'll make another function. We'll call this change owner hack. And we're going to call tp.change owner. Now it's looking for an owner address here. We could just give it our address. We could technically say match the sender, but just so it's not too confusing here, let's just give it our address. Now we do need to add the keyword public to that. This way we don't have any errors. Now something I definitely recommend here is it's kind of like Legos sometimes. Sometimes you just build, sometimes you just play around, sometimes you break stuff on purpose to understand what things will work and what things won't work. And that's kind of how you start to understand functions, especially if you're working in Remix or you're working in testnet. That's sort of how you can start to, I guess for lack of better terms, disassemble how everything works and kind of see what things work and what things doesn't, and why certain things work certain ways here. So I'm going to go and deploy this hack contract. Let's collapse the telephone down. Let's deploy the hack contract. And we can confirm this here. Cool, we can drop this down. And then we're going to call it change owner, which is going to make my wallet up here the owner of this contract. So change owner. Confirm. So my wallet is calling a function on the hack contract, which is then calling a function on the telephone contract. So again, on the telephone, according to the telephone, this message sender is going to be hack. Transaction origin is going to be my wallet there. And we can prove that if we go back to telephone and we look at the owner. Now we can see that it is 4E6 089 089. So we can go back to Ethernaut and let's see if we beat this instance here. Let's go ahead and submit the instance. And we can confirm this contract. Well, confirm the transaction, I should say. And now we can see we went ahead and we conquered this contract here. So if you guys want anything at all, or if you guys want further explanation about transaction origin versus message sender, be sure to drop me a comment down below. Be sure to subscribe if you guys want more information about this stuff here. If you guys want anything at all, be sure to give me a thumbs up. And I will see you guys in the next video at the Crypto Gym. Take it easy, guys.